Good morning, students. In previous class, that is class 1 of the chapter Surface Chemistry, already completed. The part 1 of this chapter, that is what is absorption, difference between adsorption and absorption, types of adsorption, that is physical adsorption, chemical adsorption, the characteristics of physical adsorption, characteristics of chemical adsorption, factor affecting adsorption, next adsorption isotherm, next application of adsorption. In addition to the part 2, what is the colloidal state, the classification of solution on the basis of particle size, that is true solution, suspension, and another is the colloidal solution. Next, classification of colloidal solution basing upon the 4 points. One is on the basis upon the appearance. Point 2, on the basis of interaction of phases. Point 3, on the basis of charge. Point 4, that means on the basis of molecular size. I repeat again, on the basis of appearance, mainly focused to 2 types. One is known as sol and one is known as gel. Before going to that one important thing is that 2 terms is there. One is dispersed phase and one is dispersion medium. Let us take an example in case of solution. 2 components are there. One component is in a higher extent, that is known as solvent, while another is the lower extent, that is known as solute. Similarly, in colloidal solution, solute and solvent replaced by 2 terms. One is known as dispersed phase and one is known as dispersion medium. So generally, any 2 immiscible liquid, or it is a heterogeneous, any 2 immiscible liquid form an colloidal solution emulsion. So dispersed phase may be solid, liquid or gas, as well as the dispersion medium may be solid, liquid or gas. By taking this combination, 9 types of system are there, but one, that is a gas and a gas, as it is homogeneous, not taken into account. So there are 8 types of colloidal system are possible. But normally we focus to 3 types. One is known as sol, one is known as gel, and one is known as emulsion. Repeat again. That means dispersed phase, one is dispersion medium. If dispersed phase is solid, dispersion medium is liquid, then that type of colloidal system, it is known as a colloidal system. That type of colloidal system is known as sol. Point 2, if the dispersed phase, suitable example is paints. If on the other hand, if dispersed phase is liquid, if dispersion medium is solid, then it is known as gel. Suitable example is butter. On the other hand, butter, jelly. And on the other hand, if the dispersed phase is liquid and dispersion medium is liquid, then it is known as emulsion. Suitable example is milk. That means on the basing upon the appearance. On the other hand, if it is looks like fluid or liquid, that is known as sol, and if it is looks like viscous, then it is known as gel. And normally 2 immiscible liquid, that means if phase is liquid and medium is liquid, then it is known as emulsion. All are comes under the colloidal part of solution, in which colloidal particles, that is colloids, are the size of the colloidal particle lie in between 10 angstrom to 10,000 angstrom, which particles normally pass through the ordinary filter paper but not the semi-permeable membrane. It is about on the basing upon the appearance. Next, on the basing upon the charge. If a colloidal particle is positively charged, that is known as positively charged salt. If a colloidal particle are negatively charged, then known as negatively charged salt. Generally, hydroxides are there. Ferric hydroxide, aluminum hydroxide salts comes under positively charged colloidal solution. On the other hand, metal sulfide, that is arsenic sulfide, AS2S3, cadmium sulfide, CDS. These metal sulfides are negatively charged salt. Third one is on the basis of interaction of phases. There are two types of colloidal system. One is solvent loving, known as lyophilic, generally stable, and it is reversible, not precipitated at ordinary condition. And one is solvent hating, that is lyophobic, that is not a stable one and precipitate normally. That means if the interaction between phase and medium, dispersed phase and dispersion medium, is there is or interaction, attraction is there, that is known as lyophilic or solvent loving. If the dispersion medium is water, then hydrophilic. On the other hand, if solvent hating, no interaction is there, generally unstable, non-normal condition, it is not prepared. It is prepared by a special method that is known as lyophobic, that is solvent hating. In case of if solvent is water, known as hydrophobic. It is on the basis of interaction of phases. Last one, on the basis of molecular size. Mark that. On the basis of molecular size, that is, there are three different types. One is known as multimolecular colloid. One is known as multimolecular colloid. One is known as macromolecular colloid. And one is known as associated colloid. Mark that. Depending upon the molecular size, particle size, when large number of atoms or small molecules aggregate together, join together to form a particle of colloidal range, then it is known as multimolecular colloid. On the other hand, when large number of atoms, when large size, when on dissolution come to the particle size of colloidal range, then that is known as macromolecular colloid. On the other hand, at normal condition, at a low concentration, the particles looks like true solution. That is, particles behave like normal electrolyte or strong electrolyte. But at high concentration, they associated comes closer to form the particle of colloidal size known as associated colloid. So when they comes closer, associated aggregate to form a ionic micelle, to form ionic micelle. It is known as associated colloid. So today in class 2 of the chapter surface chemistry, I will try to complete how it is the formation of a micelle. That is a suitable example is cleansing action of soap. Next is preparation of colloid, purification of colloid, and properties of colloid. Mark that today, that is in class 2 of the chapter surface chemistry. I will try to complete cleansing action of soap. Next, preparation of colloids. Next, purification of colloid. Next, properties of colloids. Next, coagulation or flocculation or precipitation. Next, Hardy-Scott's rule. Next, emulsion and its type. Let us discuss one by one. First is formation of ionic micelle, that means cleansing action of soap. It is a very important. Write short notes on cleansing action of soap or formation of micelle. 3 mark question. We know what is soap. Soap is nothing but sodium potassium salt of higher fatty acid, that is stearic acid, oleic acid, palmitic acid, etc. represented by the formula RCOONA. Suitable example: sodium stearate C17H35 COONA. That means this is represented by RCOONA. When it dissociate, break down to form RCOO minus and Na plus. This stearate ion, for example, C17H35 COO minus. This stearate ion has 2 components. One is known as head, one is known as tail. Mark that. This long chain hydrocarbon part, it is known as non-polar. It is known as hydrophobic, and dissolve in oil. It is known as tail. And COO minus, it is known as polar in nature. Polar in nature, it is hydrophilic and dissolve in water, and it is known as head. Mark that. When this grease, any grease or oil that is sticking into the surface of any cloth came in contact with the soap solution. Mark that. It is oil sticking to the cloth or grease. When came in contact with soap solution, then the stearate ion, that means I represent it RCOO minus, came in contact with this one, and mark that it is oil. Then it is oil, then it is known as water, it is known as water, it is known as polar head, it is known as non-polar tail. So what happened? When this oil or grease came in contact with stearate ion, the non-polar tail came in contact with oil part, while the polar head, that is, came in contact with water, dissolved in water part. As it is hydrophilic, that one dissolve in water and form one ionic micelle and pull out this grease from the cloth into the water. And by adding excess of water, that one forming one ionic micelle and remove from the cloth. This is known as cleansing action of soap or detergent, or that is the formation of ionic micelle. Next we discuss the preparation of colloid. Next we discuss preparation of colloid. generally already covered. That is, it is a state in between true solution and suspension. The particle size, the crystalloid of the true solution, is between 1 to 10 angstrom, less than 10 angstrom, while the particles of the suspension, that is suspension, greater than 10,000 angstrom, while the particle size of the colloid lie in between 10 angstrom to 10,000 angstrom. So two different ways there, by joining the smaller particle to colloidal size, by breaking the coarse particle, bigger particle to colloidal size, two different way to prepare colloidal. That means one is by dispersion or disintegration, and one is by condensation or association. Again, this disintegration or dispersion is carried out in three different ways. One is known as mechanical disintegration, and it is carried out by colloidal mill. And second one is electro disintegration, and it is carried out by Bradick arc method, and last one is peptidization. These are the three different ways by dispersion or disintegration, that means breaking the bigger particles into a particles of colloidal range. That is, one is mechanical disintegration, that is carried out by colloidal mill, electro disintegration carried out by Bradick arc method, and last one is peptidization by adding a suitable electrolyte known as peptidizing agent. While this condensation or association is carried out by chemical method. It is carried out by chemical method, in which the smaller particles join together to form a particle of colloidal range, and it is carried out by adding a suitable chemicals or by solvent exchange or by excess cooling. I repeat again, this is carried out by adding suitable chemicals or by solvent exchange method or by excess cooling. So let us discuss, that means by dispersion or disintegration method, and the first one is mechanical disintegration, and it is carried out by colloidal mill. What is colloidal mill? Two steel discs is there. Two steel discs rotate around a gap, little gap between it, rotate around a high speed with opposite direction. Then suspension, large particle size with usual solvent when poured down, then it is grinded to form a particle of colloidal size. That is known as mechanical disintegration, which is carried out by colloidal mill. Next one, that is electro disintegration by Bradick arc method. This method is meant for the metal sulfide, preparation of colloidal of negative charge colloid for metal sulfide. What happened? Mark that. A container is there, two metal electrode is there, strong electric arc is passed through intense, which produce intense heat. It is metal electrode, it is the solution. Next it is put again in ice bath. It is ice bath. When electric arc is struck between the two metal electrode, which is suspended in solution, intense heat is produced, as a result of which metal, on the application of intense heat, the metal vaporizes. At the same time, that container is put into another container where filled up with ice known as ice bath. On condensing, the vapor condenses to form a particle of colloidal range. This is known as electro dispersion, and this method is meant for the preparation of sulfides of metal, that is gold, silver, platinum. And third one is peptidization. That means a suitable electrolyte is added known as peptidizing agent, as a result of which the precipitate breakdown to a colloidal range, particle of colloidal range, that is known as, that electrolyte added is known as peptidizing agent, and the phenomenon is known as peptidization. It is all about the preparation of colloid. Next we discuss about purification of colloid. Next term is purification of colloid. Purification of colloid. That means the process of removal of impurities to a minimum level. That means in case of colloidal system, the impurities are suspended. The process of, and also the crystalloid. So the process of removing these impurities, either crystalloids or suspended from the colloidal solution, is known as the purification of colloid. Generally, the concept is that the size of the colloid is between 10 angstrom to 10,000 angstrom in such a way that the particles normally pass through the ordinary filter paper but not through the semi-permeable membrane. So, one instrument, first Graham's invented one instrument for purification of colloid from crystalloid, that is known as dialyzer. The instrument is known as a dialyzer, as first invented by Graham's, that is known as Graham's dialyzer. And the process of purification, process of removal of impurities, that is crystalloid from colloid, is known as dialysis. The principle is that the solution, when poured through a semi-permeable membrane, the crystalloids, as particle size is smaller, then move through the pores, small pores, leaving behind the colloids. That process is known as dialysis, and the instrument used known as a dialyzer. Graham's invented first, that is known as Graham's dialyzer. And another process is there. Besides this, another process is there known as ultrafiltration. Ultrafiltration. We know ordinary filter paper, the porous size is too large. It is necessary to reduce the porous size of the ordinary filter paper. That's why it is necessary that ordinary filter paper is soaking into a gelatin solution and making harden to dissolve in formaldehyde solution. Then the pores of that ordinary filter paper is reduced and is such that it did not allow the colloids but only allow the crystalloid. That filter paper is known as ultrafilter, and the phenomenon, the process of separation of crystalloid from colloid is known as ultrafiltration. It is all about the preparation and purification of colloid. Next switch over to the properties of colloid. What are the different properties? Mainly focus to 3 points. One is known as mechanical property, one is known as electrical property, and one is known as optical property. Let us discuss one by one. that is properties of colloids. That is point 1, mechanical property. Mechanical property, that is Brownian moment. Brownian moment. Next one is optical property. Optical property, that is known as Tyndall effect. Tyndall effect. And third one is electrical property. Electrical property known as electrophoresis. Electrophoresis. Let us discuss one by one. First one is mechanical property. That is Brownian moment. As first one identified by British botanist Robert Brown. He observed that the colloidal particles move rapid random zigzag motion due to the bombardment of colloidal particle among itself. This phenomenon not depends upon the nature of the colloids, but it depends upon the particle size and viscosity of the colloid. So solution. That means smaller the particle size or lower the viscosity, then movement of the colloidal particle is a maximum. And this is due to the unequal bombardment of colloidal particle, as it was first identified by British botanist Robert Brown, so it is known as Brownian moment. Move to second one, that is known as optical property, and it is known as Tyndall effect. What is the optical property? Mark that when a converging beam, two type of beam already you know, one is a diverging and one is a converging. When a converging beam of light allowed to pass through a colloidal solution, then the path of beam becomes illuminated. A bluish cone is observed if one is observed that is perpendicular to the propagation of light. As Tyndall first invented, that effect is known as Tyndall effect, and that bluish cone is known as Tyndall cone. Mark that. It is the source of light. It is the thin slit. Again, it is the solution, colloidal solution. Mark that. It is looks like path becomes illuminated, look like bluish cone. If one is observed that is perpendicular to the direction of propagation, then this is known as a bluish cone. It is known as a Tyndall cone, and this effect is known as a Tyndall effect. Some examples: sky or sea looks blue. That means the comet, that a twinkling of a star. These are some common example of this optical property. Next one is electrical property or electrophoresis. Next is electrical property. Electrical property, or it is known as electrophoresis. We know that colloidal particles may be positively charged or negatively charged. So, when electric field is applied in the colloidal solution, which two platinum electrode deep in the colloidal solution, and electric potential is applied, then there is a migration of colloidal particle to their respective electrode. This migration of opposite charged colloidal particle to their respective electrode under the influence of electric field is known as electrophoresis. It is the electrical property of colloidal solution. Next, we discuss another one term, that is coagulation or flocculation or precipitation. Next, we discuss coagulation or flocculation or precipitation. What do we mean by coagulation? The small particles, when comes closer by addition of suitable electrolyte, by addition of suitable solvent, which neutralize the colloidal charge particle, as a result of which comes closer and form a precipitate. That phenomenon is known as coagulation or flocculation or precipitation. That suitable solvent, that suitable electrolyte is added is known as coagulating agent. And the minimum concentration of the coagulating agent added per liter of the colloidal solution to make the coagulation or flocculation is known as its coagulating power or flocculating power. Generally, smaller is the coagulating power, higher is the tendency to cause coagulation. Basing upon this, one rule is there, that is known as Hardy-Scorch rule. Mark that. What is this rule? This rule states that higher the valency of the coagulating agent added, higher the valency of the coagulating agent added, higher is its power to cause coagulation. I repeat again. This rule states that higher the valency of the coagulating ion or flocculating ion added, higher is its tendency to cause coagulation. For example, if two types of salt is there, one is a positive salt and one is a negative salt. Mark that. Aluminium hydroxide, ferric hydroxide, these are known as positive salt. And if positive salt is there, then we have to add negative electrolyte and their decreasing charge, decreasing valency. Mark that. FeCN6 4 minus, PO4 3 minus, SO4 2 minus, Cl minus. Mark that. That is decreasing order. Higher the valency of the coagulating ion added, higher is the tendency to cause coagulation. Similarly, for negative salt, if you select metal sulfide, generally AS2S3 CDS, this is known as a negative salt. If it is negative salt, we add positive charge electrolyte, that is L3 plus, Ba2 plus, Na plus, that is decreasing order. Higher the valency, I repeat again, this rule states that, higher the valency of the coagulating ion added, higher the tendency to cause coagulation. Last, we discuss emulsion. What do we mean by emulsion? Already we covered. That means emulsion nothing but one colloidal system, heterogeneous colloidal system in which dispersed phase and dispersion medium both are liquid. Generally, any two immiscible liquid form an emulsion. It is of two types. It is of two types. That is point 1, oil in water type. That is O by W type. And second one, water in oil type. That is W by O type. Let us discuss one by one. First one is oil in water. Oil in water means here in this case oil is the dispersed phase while water is the dispersion medium. While water is the dispersion medium, the continuous phase that is known as water, while oil is the dispersed phase. That means small oil droplets are floats over the water. This is known as oil in water type. Suitable example, that is O by W type. Suitable example is milk. Next one is water in oil type. Next one, water in oil type. Water in oil type, this one is known as dispersed phase, while oil is known as dispersion medium. The continuous phase is the oil and water is known as dispersed phase. That means small amount of water molecule floats over the system containing oil. It is known as water in oil type. And suitable example, that is water in oil type. Suitable example is butter. It is all about the emulsion and type of emulsion. And also it is all about the chapter surface chemistry.